let us solve some more questions. Now in this question it is cosecant theta minus sine theta, secant theta minus cos theta, right? Cosecant theta is nothing but 1 by sine theta, so this can be written as 1 minus sine square theta divided by sine theta. Secant theta is 1 by cos theta, so it can be written as 1 minus cos square theta by cos theta. Tan and cot, if I bring in sine and cos, sine by cos is tan, sine by cos, and cot theta is cos by sine. Now if you see, this is nothing but cos square theta and this is nothing but sine square theta. So I can write cos square theta and here it is sine square theta. Okay, in the denominator I've got sine theta and cos theta, so let me write it here, sine theta cos theta. Okay, and here in this bracket I can multiply it with this sine square theta and then this with this cos theta with cos theta, so it will become cos square theta and denominator will be sine theta into cos theta. So this sine square theta plus cos square theta is anyway is equal to 1, and sine theta into cos theta and sine theta into cos theta will cancel this also. So the entire expression will become equal to 1, hence will give me my answer option B. In this question, if you see, we need square terms like b square x square, a square y square, etc. But we are given x equal to a cos theta, y equal to b sin theta. I told you while telling about this identity sin square theta plus cos square theta equal to 1 that we should be careful, like we should be very attentive where to apply this. So if you notice this given expression, we can rewrite this as this: x by a is equal to cos theta, y by b equal to sin theta. Now if you see, we can square these two expressions and add, right? Because if I square these, it will become cos square theta equals this, sin square theta equals this expression, right? This is sin square theta. Now if I add these two expressions, on the right hand side I'll have sin square theta plus cos square theta, which is 1. On the left hand side I'll have x square by a square plus y square by b square. Okay, and what I require here is b square x square plus a square y square. So this I'll replace by 1. Now to solve this, I'll multiply this with x square, so it will be b square x square plus a square y squared, and in the denominator I'll have a square b square, which will go to the right hand side like this. So the required expression is equal to a square into b square. Alright, let us work on the next expression. I think it will be very simple for you to work on the next expression, because secant theta is equal to x by a, tan theta is equal to y by b, and you know that secant square theta minus tan square theta is equal to 1. So you can simply square these and subtract secant square theta minus tan square theta, right? So you will have secant square theta minus tan square theta on the left hand side, which anyway will become 1, and on the right hand side you will have x square by a square minus y square by b square, and which can be manipulated further as b square x square minus a squared y squared divided by a square into b square. So this expression is equal to a square b square, because it will go to the right hand side or the left hand side. So a square b square is the answer for this question also. Alright, let's move to the next question. You do not need to be afraid of these expressions cot 3 theta, tan 3 theta. In class 10th, I am not going to tell you the direct formula for these trig ratios. But for the manipulation purpose, what we can do is cot theta can always be written as 1 by tan theta, right? So cot 3 theta can always be written as 1 by tan 3 theta, right? When I say always be written as, I am saying that wherever it is defined, right? Wherever the denominator doesn't become 0. Alright, so beware of what you speak in mathematics class. Alright, so let's bring this first term in terms of tan. So the numerator can be written as 1 by tan theta, denominator can be written as 1 by tan theta minus 1 by tan 3 theta. Let us further manipulate it. 1 by tan theta divided by, this will become tan 3 theta minus tan theta divided by tan theta tan 3 theta. Now if you notice, this tan theta and this tan theta can be cancelled, and this tan 3 theta will go in the numerator, and denominator will become tan 3 theta minus tan theta, right? But here I've got tan theta minus tan 3 theta. So what I'll do is I'll change this sign to negative, and the denominator will become the same, right? So if I change, now let me write the first term, this term, as tan 3 theta divided by tan 3 theta minus tan theta, right, which is this. Now let us change the sign to negative, and the denominator now will become tan 3 theta minus tan theta here, and in the numerator I have got tan theta. If you notice, the denominators are same, so I can write tan 3 theta minus tan theta, and the numerator is also tan 3 theta minus tan theta. So these can be cancelled and put equal to 1. So this was a simple manipulation, okay? Just tan theta and cot theta are reciprocal of each other. This was only the fundamental that I used. Okay. Now in this question, I think the identity, we should use the identity sine square theta plus cos square theta equals 1. See, let me show you some manipulations. If I square this identity, what will I have? Sine 4 theta plus cos raised to power 4 theta plus 2 sine square theta cos square theta equal to 1. Okay, so I can replace this by this expression by 1 minus 2 sine square theta cos square theta, right? So this is the expression that I have got here, and for using the sine 6 theta and plus cos 6 cos raised to power 6 theta, let me cube this identity on both sides. So sine raised to power 6 theta plus cos raised to power 6 theta plus 3 sine square theta cos square theta, and then sine square theta plus cos square theta in the bracket, and let us put it equal to 1, because if I cube the right hand side it will still give me 1. So this sine raised to power 6 theta plus cos raised to power 6 theta, this will anyway become 1. So this can be replaced with 1 minus 3 sine square theta cos square theta. Or you should directly know the formula for a cube plus b cube, right? And a squared plus b squared. So anyways, let us replace what we have got. Twice of this expression in the bracket, I am replacing it with this one. 1 minus 3 sine square theta cos square theta minus thrice of sine raised to power 4 theta plus cos raised to power 4 theta. I am replacing with this 1 minus 2 sine square theta cos square theta. Now look at this. This will become 2 minus 6 sine square theta cos square theta, and this is minus, give me a moment, this is minus 3, then minus minus plus 6 sine square theta. Okay, give me a moment please. All right, 6 sine square theta cos square theta. Now see, this can be cancelled, and 2 minus 3 will give me minus 1, which is option 3. So this was just the application of this identity that we learned. All right, okay, let us look at the next one. Next one is also the application of the same identity that we just discussed, because we have got a as coefficient of cos theta and a as coefficient of sine theta. So if I square and add these two, then I'll be able to get rid of sine theta and cos theta, because in the expression, in the answer, I do not require sine theta and cos theta. So let me square this. It will become a square cos square theta plus b square sine square theta plus 2ab sine theta cos theta, and on the right hand side I've got 16. When I square this one, I'll have a square sine square theta plus b square cos square theta minus 2ab sine theta cos theta, and on the right hand side I'll have 9. Now if I add these two expressions, this will be cancelled, and from the first terms I'll have a square common. Inside I'll have sine square theta plus cos square theta. This was my purpose, right? To bring it in this form, because I can simply replace sine square theta plus cos square theta with 1. And some of these second terms will give me b square into sine square theta plus cos square theta inside the bracket, and on the right hand side I'll have 25. So this is 1, this is 1. So a squared plus b squared is equal to 25, which is your option C. Right? This was another question based on sine square theta plus cos square theta equal to 1. This is a very simple question, because this question itself tells you what to do, right? This wants you to square these two equations and subtract this from this, right? So the question itself is telling you what to do. So let me square this. P squared is equal to a square cot square theta plus b square cosecant square theta plus 2ab cot theta cosecant theta. And let me square this one now. Q squared is equal to b square cot square theta plus a square cosecant square theta plus 2ab cot theta cosecant theta. Right, now the expression that I require is p square minus q square, so let me subtract. When I subtract these, this will be cancelled, and let me tell you, let me use this term and this term first, because there is b square in these terms. So let me take b square outside and write cosecant square theta minus cot square theta. I hope you know where it is going now. So now let me subtract this term from this term. So it will give me plus a squared cot square theta minus cosec square theta. So cosec square theta minus cot square theta is equal to 1. So this will be equal to minus 1. Hence answer that I am going to write is b square minus a square. Or what you can do is you can take negative common and write cosecant square theta minus cot square theta inside. Otherwise, this much you should already know, that if cosecant square theta minus cot square theta is equal to 1, then what will be cot square theta minus cosecant square theta? Right? So the answer is b square minus a squared. Let me see what is next. This question is pretty simple. Sine square theta plus sine square of 29 degrees plus sine squared of 61 degrees. Now we know that 61 and 29 are complementary. What I mean is 61 degrees plus 29 degrees, sum of these is equal to 90 degrees. And we know that sine 90 minus theta is equal to cos theta. So what I can write is sine 61 degrees can always be written as cos 29 degrees, right? This is what we know. So we can simply write sine square 61 degrees as cos square 29 degrees. So this expression becomes sine square 29. I hope you have already got the answer, cos square 29 degrees. So this is equal to 1, right? Next one, although the answer is giving you an idea that we need to square these terms, and then we will see which answer will be correct. So if I square this, I'll get x squared is equal to r squared sine square theta cos square phi. If I square the second one, I'll get y squared equals r square sine square theta sine square phi, right? And in the third expression, I've got z, so z squared is equal to r square cos square theta. So one thing is sure, that I need to get rid of this sine theta cos phi, right? So how do I do that? I already know that sine square theta plus cos square theta is equal to 1, right? Or sine square phi plus cos square phi is equal to 1. This is what I know. If you notice that if I add these two, then r square sine square theta will be taken as common, and sine square theta plus cos square phi will become 1. So let me do this first. I am adding these two equations. So x square plus y square will become, let me take r square sine square theta common, and inside I'll have cos square phi plus sine square phi, okay, which is equal to 1. So x square plus y square I know is equal to r square sine square theta, and z square I know is r square cos square theta. So we can notice that if I add this expression and this expression, then I'll be able to take r square common from the right hand side, and I'll get this expression sine square theta plus cos square theta in the bracket. So let me add this expression, this equation and this equation. So I'll have x square plus y square plus z squared equals, now let me take r square common. This is already gone, right? This is equal to 1. So let me take r square common. Sine square theta plus cos square theta will be inside. So we know the answer, that x square plus y square plus z square is equal to r square, because this is equal to 1. So this is the answer, right? Let us attempt this last question, because I think these many questions are enough for you to understand the fundamentals that I've taught you. So sine theta plus sine square theta is equal to 1. So what can I deduce from this? That sine theta is equal to 1 minus sine square theta. 1 minus sine square theta is equal to cos square theta. So sine theta is equal to cos square theta, and this is what I require, right? So cos square theta plus cos raised to power 4 theta is what I am looking for. Cos square theta is nothing but 1 minus sine square theta, right? And which is equal to sine theta in this case, right? In this question, as per this given information, right? This is not always true, okay? This is what we are manipulating based on the given information. So cos square theta can directly be replaced with sine theta. So let me replace it. So it is sine theta. So if cos square theta can be replaced with sine theta, then square of cos square theta, that is cos raised to power 4 theta, can be replaced with square of sine theta, that is sine square theta. So this is nothing but sine square theta. So this expression and this expression, these are same expressions. So now I am looking for value of sine theta plus sine square theta, which is given in the question. Sine theta plus sine square theta is given as 1. So my answer is 1. So this is also 1. Okay, so option B is the correct option. I hope these many questions are enough for us to understand the fundamentals that we have studied till now.